Okay, this discussion is on phase diagrams. This will be the last of our discussions over Chapter 10. Phase diagrams are basically used to show the relationship between the state of matter for a substance and the pressure and temperature conditions. Here's a typical phase diagram. Some things to note about it are it has these three regions here typically. We'll see one where that's where sometimes we can have more than three regions. But here the line between the two regions, in this case between liquid and gas, that line represents pressure and temperature conditions under which both phases can exist. Okay, so you would expect in this case that under the conditions represented by points on this line that you could have condensation or evaporation going on at that line right there, or at those conditions. Okay, similarly, here's our sublimation line, the line between gas and solid, which it's really sublimation if you're going from solid to the gas, deposition if you're going back the other way. But basically the thing to remember is that both conditions or both states can exist under these conditions. Okay, here's our fusion curve. Melting, freezing can occur along this line here. All right, we have the triple point. This is the pressure and temperature combination under which all three phases can exist. And then we have the critical point up here. And what you'll see is that the critical point is the temperature that once you get above this temperature, you cannot compress the liquid. You can't increase the pressure enough to make the substance behave as a liquid. And we're going to look at a particle level view of this in a little bit. But you have this region around here that is defined as a supercritical fluid. And that's basically an area where we see properties, a given state of properties that really aren't either like a gas or like a liquid. Okay, we talked about this before. The boiling point is our temperature at which the vapor pressure of the liquid is equal to our atmospheric pressure. And the normal boiling point is the boiling point at 1 atmosphere of pressure. So you can use a phase diagram to determine what the normal boiling point is, as well as the normal melting point. Critical temperature, again, that's the highest temperature at which the substance can exist as a liquid. And critical pressure, that's our vapor pressure at that critical temperature. Okay, and then that point on the phase diagram is called the critical point. All right, and here's kind of showing you what's happening at the particle level. So here we have, this would be typical room temperature for a substance, and we would have some vapor, some liquid here. As we increase the temperature, we're going to end up with a higher amount of vapor relative to the amount of liquid. And then once we get past our critical temperature, we end up with, like I said, this sort of supercritical fluid that really is not exactly like a liquid and not exactly like a gas either. Here is a phase diagram for carbon dioxide. Okay, and an easy way to identify this, a couple of features to note on this one. This is a fairly common one that you'll see. If we look at 1 atmosphere, which is right around where normal pressures are, and if we look here, what we see is that at 1 atmosphere, CO2 sublimates, which if you've ever observed dry ice, then you know that to be true, that under normal conditions, room conditions, carbon dioxide does not melt, it sublimates. Okay, here's the phase diagram for water. The way we could identify this if it wasn't labeled, a couple of ways. You could take at 1 atmosphere, run a line across here, and our liquid solid line, it should intersect 1 atmosphere at 0 degrees Celsius, and it should intersect the liquid gas line at 100 degrees Celsius. So you can identify a substance or get some information about a substance by looking at its normal melting and boiling points. Another feature about water is that the liquid solid line has a negative slope to it. Okay, and if you look at other phase diagrams, typically it'll have a positive slope. Okay, and here's the last one I wanted you to look at is sometimes we have substances that have different forms of being a solid. And so when that occurs, you'll see multiple solid regions, like we have 2 of these here, and they're calling it an alpha and a beta. But 2 regions for the solid in there, and then there's your liquid here and your gas. So sometimes we can have more than 3 regions on our phase diagram. Okay, let's take a look at this question here before we finish up. Here, if we are, let's just pick a pressure. So as we are cooling down our substance, it looks like as we cool it down, it's going to go from being yellow to being red.